and sharing my screen. And again, like we just discussed, today we're going to go over that exam 4 review. That homework 8.7 that deals with mortgages is due today. If anybody has questions on that, we can go over it. Exam 4 should be available from today until Sunday. And Sunday, that should be an N and not an M. I got to tilt this thing down. It's hard writing on a surface that's perpendicular to the table. It'll be due on Sunday at 11:59 p.m. Not Sunday, I apologize. I said that wrong. That's Saturday. I ask that you do it by Saturday so that I can get them graded on Sunday so that you are well informed in your decision as to whether you're going to take that final or not. Project 4 will be due on the 3rd, which is Monday. Please submit that in either in Blackboard. If you've had problems with Blackboard submissions, you can also email it to me. But again, I would prefer if you submit it in Blackboard. The last day that you can work on My Math Labs is on Sunday. After that, anything that's not done will be replaced with a 0. And hopefully by, I'm doing this for all of my classes on the same day. So I think Monday is ambitious because I've got a lot of tests to grade on Sunday. I think every class I teach has a test that's due on Sunday. What was I thinking? But hopefully by Tuesday or Wednesday that My Math Lab average will be accurate in Blackboard. The final will be due by the end of the day on Wednesday, the 5th. That's at 11:59 p.m. Again, that final exam will be optional. Realize, though, that if you take it, I will drop the lowest test grade. If you decide not to take it, by default, that will be the grade that will be dropped, and I'm not going to drop another test grade. So, I guess I should add, folks are asking, Monday, the 3rd will be the last day where attendance is mandatory. On Wednesday, the 5th, I'll be available in Zoom like a office hour. And on Friday, the 7th, I can be available during class time by appointment. Otherwise, I probably won't be sitting in front of the computer all day Friday, unless people want to go over something. And again, I don't have a problem doing that at all. Actually, I would love to see you guys again if you had any last minute questions on anything. Otherwise, I guess that's the end of the semester. Does anybody have questions on any of that? Does that answer all of your questions about the next week and a half?
Wednesday, the Zoom, is that going to be like during class hour?
Yeah, it'll be during class time.
Okay.
So, so that before you, last minute, before you take the final, if you have any questions, I'll be there for you. Okay. Then before we start looking at that test for review, does anybody want to look at any anything at all in any of the My Labs homework? Not hearing from anybody, then what I'm going to do is I took the liberty of uploading that test for review into the form for today's notes. And so let's go over this. And again, on Friday, we'll go over that final review. And oops, let's go back. Well, all of them are in with the notes for Unit 4. So your test, again, will be very, very similar to this.
That's different than the one that I have.
Is it? What's the one that you have, say? What's the number? What?
I printed mine's out, and why is it different than the one you have on the screen?
The first
What's
question,
the first
for ours
question? Go ahead.
the first question for ours says express the given fraction as a percent, and then it says 3/8. Yours says 5.
Okay, all right, give me just a second.
Yeah, all the questions are different. They're similar, but they're different numbers.
Right, and I have to apologize. In the other section, the one that I went over with them was the 3/8, and what they had in Blackboard was 5/8. And so I have no idea. I thought I had done the same one for both classes. So let me just real quick go over here. I thought I had checked it this morning and saw that this was 5/8. Let me just real quick double check. Yep, yours is 3/8. So let me download this. Let me put this, I guess I'll put it in Amy. And let me go back here and let me add a page and let me insert. Does that look better? Oh, wait, we're waiting for it to come up. Excuse me. Does that look better?
Yes.
Yes.
Okay. I do have the answers done out for that one with 5/8. I did them again for the other section yesterday. So that will be at the beginning of today's notes. And I will, if you want a second practice, I can attach those solutions in Blackboard somehow later. Would anybody be interested in that? Okay, I guess not, then I won't attach them. So if you remember correctly, the chapter started with pretty straightforward stuff that hopefully everybody was familiar with. So I'm going to ask a little bit of help here. Can anybody remember remind me, how to change a fraction into a percent? Okay, let's start with a simpler question. Can anybody remember how to change a fraction into a decimal?
Divide it.
Divide it. And so 3 divided by 8 gives me 0.375. And now that I have that decimal, how do I change that decimal into a percent?
You move the decimal place over to the right 2 spaces.
And so you folks remembered how to do that. You just forgot that there was 2 steps to it. To change a fraction into a percent, it's probably easiest if you first change that fraction into a decimal and then move your decimal point. So having seen that one done, can I ask you folks to please do the same work for 3/8? Whoops, I got to turn the calculator on. 3/80, and tell me what you get.
0.0375.
And so what would that be as a percent?
We would move it, so it's going to be 3.75.
Beautiful, 3.75%. And is everybody comfortable with that?
Yeah.
And so obviously you folks just showed me that you know how to change that decimal into a percent. So where we have 0.7645, what would that be as a percent?
76.45.
76.45%. Great. And again, that process is the same if what you're starting with is a whole number. Here I have 5.86. That's that decimal. When I move that 2 places, that'll be 586%, which I know sometimes students think that looks odd, but realize that anything larger than 1, the whole number 1, will be bigger than 100%. So far, so good.
Yes.
Yeah.
Then next question says, an exercise machine with an original price of $750 is on sale for 18% off. The first thing we want to do is find the discount amount. To find the discount amount, that's 18% of the cost, $750. Can anybody remind me what we did to find a percent of a number?
Multiply?
Yep, I'm going to change that percent first into a decimal though. Make sure you rewrite it as a decimal and then multiply. And so when I take 0.18 times 750, I get that the discount is $135. And so if the discount is $135, what's the sale price? How would I find that?
Subtract.
So when we take 750 minus 135, what are we getting?
615.
I think it's going to be 515. Be careful if you're subtracting by hand. Remember that. No, wait a minute. You're right. I have no idea what I'm thinking. 615 is right, and I was off. I apologize.
I laugh on questions like that. Would it take it if we just put it like that, or do we have to do the period and the 2 zeros after?
I think it'll take it just like that.
Okay.
And again, this is why I ask you to please send me pictures of your work so that I can give you partial credit. And if I realize that they wanted the periods and the 2 zeros and you didn't put them there because they're not necessary if it's a whole number, I would give you full credit for that. Okay. So next one says a sofa regularly sells for $880. The sale price is $827.20. Find the percent decrease of the sale price from the regular price. And again, does everybody remember to find the percent decrease? The first thing that we have to do is find the decrease, which is subtract. How much money is being taken off? 880 minus 827.20. How much is that price going down?
$52.
$52.80. And so now they say you want the decrease from the regular. And so what we're going to do is we're going to put the decrease over the original. And so that would be 52.80 over the 880. And now we've got that fraction. We're going to turn that into first a decimal and then a percent. So that's 0.06, which is 6%. And again, to reiterate, give me your work and I'll go through and check for partial credit, because silly things like if you typed another percent sign in there, my labs would say it's wrong, but I would realize that it's a typographical error and give you full credit. Is everybody okay with that one? Remember, when you're looking for the percent change, the percent increase or the percent decrease, you subtract to find the difference, and then you always put it over what would have been the original value. Now, again, I'm going to stop for a minute and go back to the Unit 4 and suggest that for everybody, I know in my lab, sometimes they give you formulas, but sometimes they don't. So I would strongly suggest that you take this formula sheet and have it opened to use while you're taking the test, or print it up to have while you're taking the test. I'll have a slightly different formula sheet in there for the final exam because I gave you formulas for this unit, and I also gave you formulas for that preceding unit on statistics. So going back, we know that this is simple interest, and we're looking at finding P when we know A. And so simple interest, finding P when we know A. Does everybody see we use that second formula under simple interest? And so that formula is A equals P times 1 plus RT. Again, I had said in order to give you full credit, I'd ask that you please identify your variables, but they've done that for us. However, you have to remember, here the rate is given as a decimal, a percent. We want to change that to a decimal. And here the rate is given in months. We want that in years. So in years, it would be 3/12. So substituting, that gives me that 8,000 is equal to P times 1 plus R is 0.15 times T is 3/12. And then, is everybody familiar with the idea, order of operations? You do what's inside those parentheses first. So we'll take 1 plus 0.15 times 3/12. And that gives me that 8,000 is equal to 1.0375 times P.
How come on the formula it doesn't show a fraction at the end?
Oh, because here T is given in months and we have to change it into years. That's because our time is a fraction of a year. It's less than a year.
Okay.
Okay. And then again, to solve an equation for P, if we're multiplying by a number, we'll have to divide both sides by that same number. And so when we take 8,000 and divide it by that last answer, we get that I get 7710.843373. They ask you to round up to the nearest cent. So normally to the nearest cent, we'd say 84 cents, but because they ask us to round up, we'll say that that's $7,710.85. Next question is also just asks for simple interest. And since it's just asking for the simple interest, we're going to use that simple interest formula, I equals PRT. P is at 12,500. R, we have to write that as a decimal, so that 12% is 0.12. And T, they say, is 60 days. 60 days is less than a year. It's a fraction of a year. And up here, they tell us to assume that there's 160 days in a year. So our time will be that fraction 60. I'm sorry, I said 160 and I should have said 360. Our time will be that fraction 60 over 360. So substituting, I'll get I equals P, which is that 12,500, times R, which is that 0.12, times T, which is that 60 over 360. And again, I'm using parentheses to show that I'm multiplying those values. We don't need to type those parentheses in. We'll just put a multiplication sign in between. So we'll take that 12,500 times 0.12 times 60 divided by 360. And so for the simple interest, I get $250. To the nearest cent, so I guess here we probably should add the 0.00 to show that there is 0 cents. Again, do you see, they say don't round to the final answer, then round. If you would have changed that fraction into a decimal, you would have gotten a repeating decimal and rounded at some point in time, and you would have gotten a very slightly different answer. And so that's why I strongly suggest you type things in the way they're written all at once and not divide it into little steps. Is everybody comfortable with that one?
Yeah.
Great. Then next one says, the principal P is borrowed at a simple interest rate. Find the loan's future value A, or the total amount due. Well, simple interest involving A, that would be the formula we used before, A equals P times 1 plus RT. We know that P is that $38,000. R is 8%. Again, we want to write that as a decimal, which would be 0.08. And T is 5 years. Because it's in years already, we're going to just use that number 5. So substituting in, we'll get A equals 38,000 times in parentheses 1 plus 0.08 times 5. And here we've got all of the numbers on that right-hand side. So using the parentheses key, we can just type that right in, 38,000 times, I'm gonna open my parentheses, 1 plus 0.08 times 5, close my parentheses. And so to the nearest cent, I get $53,200 even. Is everybody all right with that one?
Yeah.
Next one then says the principal represents an amount of money deposit in a savings account subject to compound interest. We want to know how much there will be after the given number of years. So we're looking for the future value. So again, compound interest, looking for the future value. I'm going to use this A equals P times 1 plus R over N to the NT. Remember, A represents future value. So here my formula is A equals P times 1 plus R over N, close parentheses, to the NT. Here, we know that our P, our principal, is $5,000. Our rate is 8%. Don't forget to change that into a decimal, 0.08. Quarterly, does everybody remember that means that N is 4? We're doing it 4 times a year. Our time is given in years, so that'll be 5. Remember, we had suggested multiplying n times t. 4 times 5 is 20, so that we just have a single number to put in that exponent. So substituting, that gives me A equals 5,000 times 1 plus 0.08 over 4, close parentheses, to the 20th. And so if everybody could type that in their calculator, 5,000 times parentheses, 1 plus 0.08 divided by 4, close parentheses, exponent 20. I'm getting that A is equal to $7,429. And they ask you to round to the nearest hundredth, to the nearest cent. So that would be 74 cents. Is everybody else getting the same?
I did.
And then with a question like this, with compound interest, does everybody remember that the amount of the interest is the difference between what you get out and what you put in? So here that would be the 7429.74 minus the 5,000. And so the interest would be $2,429.74. How are we doing?
Good.
Yeah,
Right.
good.
Next question then asks us to find how much should be deposited today in an account that earns 6% compounded semi-annually so that it will accumulate to $9,000 in 3 years. Does everybody recognize here that that $9,000 is my future value? So A is that $9,000. And we're looking for P. Our rate is at 6%. Semi-annually means twice a year. We're doing it for 3 years, I apologize, 3 years. And so the product and T is 6. I apologize, my writing's getting bad. The stylus either doesn't recognize it at all or is too heavy. And when it's too heavy, if I don't lift the pen up right, it gets those squirrely lines around it. So again, going here, if we know A and we're looking for P, that's when we use this fractional version of that formula. And so that gives us that P is equal to A over parentheses 1 plus R over N, close to the NT. And so substituting, that would give me 9,000 over parentheses 1 plus R is 0.06 over N is 2 to the NT is 6. And so we'll just type that right into our calculator, remembering first we'll put in that numerator, 9,000, and then to get that bar for the fraction, we'll use division. So we'll take 9,000 divided by parentheses, 1 plus 0.06 divided by 2, close parentheses, carry it up, to raise that to the 6th power. And so it says round up to the nearest cent. My calculator gives me 7,537.358. And so I would round this one up anyways. And so my answer, will be $7,537.33. $0.36. Is that one all right?
Yeah.
Then next question asks us to compare two investments. To do that, we're looking for that annual yield, and they are compounded. And remember that annual yield was that formula under compound interest where it's y equals. So here for both of these, we'll use that formula, y equals parentheses 1 plus r over n to the n minus 1. Got a lot of room at the bottom of the page, so I'm going to do my scrap work down here for the 14% monthly. My R is 0.14 or just 0.14. Monthly N is 12. And so when I substitute, I get Y equals parentheses 1 plus 0.14 over 12, close parentheses, to the 12th minus 1. And so we'll just type that right in parentheses 1 plus 0.14 divided by 12, close parentheses, to the 12th power. If your calculator at this point gives you superscript, if it looks like an exponent in your calculator and it's typed small, you have to arrow out of the exponent. Then we'll type the minus 1. And so, yep, I know I typed something in wrong because that answer wasn't right. I just mistyped, I apologize. I get that that's 0.149342, which would be 14.9342, or to the nearest hundredth, 2 decimal places, it would be 14.93%. We're going to do that same thing again for the 14.25% annually. So here R is 0.1425, and annually is once a year, so N is 1. And so this gives me Y equals 1 plus 0.1425 over 1 to the first minus 1. And I'm going to shut off and ask you folks to give me that answer.
I got 0.1425.
0.1425, beautiful. So as a percent, that would be 14.25%. So which is better? Which would you rather earn, the higher percent or the lower percent? I'm thinking the higher. And so we want that 14% monthly. That one okay.
Yeah.
Yes.
Then next question, they give you the formulas down below. You're asked to use the appropriate formula to find the value of the annuity. Here we know the deposit. If we know the deposit, we're looking for the future value. And so that will be this middle formula. And in the interest of space, are you guys all right if I don't rewrite the formula?
Yes.
Yes.
Again, I would ask you to write the formula that you choose on the paper in which you show the work. So here we know that our deposit P is 50. Our rate is a decimal is 0.06. If it's compounded monthly, N is 12. We're doing it for 30 years, so T is 30. So putting those last two together, NT would be 12 times 30, or 360. And so when I substitute into that formula, I get A equals P, which is 50, times parentheses, parentheses. Remember, the two parentheses are important. 1 plus 0.06 over 12, close parentheses, to the n times t, that exponent is 360, minus 1, close those parentheses, and put it all over that 0.06 over 12. Again, those parentheses in the denominator are important. So typing that in, oh, and obviously I mistyped because that answer is still, oh, it would always help if you make sure you hit the division sign instead of the multiplication sign. Yeah, that looks a little bit better. Is anybody else getting that in the future? They'll have $50,225. Round to the nearest dollar, I've got 752. So to the nearest dollar, it would be 50,226. Now, again, this is the amount of money that I'll have after 30 years. The interest is the difference between what I put in and what I take out. But we have to figure out what we put in. And you guys remember to find the total of the payments. We're going to take that payment and multiply it by NT. Or basically, we're saying we're paying $50 for 360 times. And so altogether, we're paying 50 times 360. So of that, we're putting in $18,000. And the interest, again, like we did with compound interest, the interest is the difference between the money we get out and the money we put in. And so when we do that subtraction, the interest earned is $32,226. How is that one?
Good.
Good.
Great. The next question is also an annuity question, but with this one, we don't know how much we want to put in, but we know when it's all over, we want to have that $220,000. So this time we're using that last formula that solved for P. This time that $220,000 is our A. Our time is 15 years. Our rate as a decimal is 0.065. Monthly means we're doing it 12 times. So when I look at N times T, 12 times 15, we'll be making 180 payments. And P is what we're looking for. So here, substituting in, we'll have P equals A, which is my 220,000, times parentheses, my R, 0.065, over my N, which is 12, all over, parentheses, parentheses, 1 plus 0.065 over 12, close, to the NT would be to the 180th, minus 1, close. And so now when we type this in, Is anybody else getting 724.769? They ask us to round up to the nearest dollar, so that'll be $725. Here to find out how much comes from the deposit, well, we're depositing $725, again, multiplying it by NT 180 times. So when I take 725 times 180, we're putting in $130,500. And so for the amount that's interest, that's the difference between what we get out and what we put in. And so here our interest is $89,500. And how's that one?
Good.
Good. I'm looking at time and we have 2 questions left to do. Question 15 is a car loan that just asks you to use the payment formula. I'm going to skip over that one for a second and look at question 16 because it's a mortgage one. And with the mortgage one, we have to use that same formula. But we've got to do a couple more things. So if we have time, we'll go back and look at the car loan. If we don't have time, I do have that worked out for my other class last night. I'll fill it in before I post the notes. So 16 says we're going to use that payment formula to find the regular payment amount to the nearest dollar. The price of the home is $100,000. The bank requires 20% down, 3 points at closing. The cost is financed with a 30-year fixed rate mortgage at 7.5%. We're asked to find a whole bunch of things. The first is the down payment, and the down payment is 20%. And so that means we'll take that 20% and multiply it by the cost of the house, which gives us that our down payment is $20,000. The amount of the mortgage is the difference between the price and the down payment. Or if we're buying a house for $100,000 and we already have $20,000, that means that we still have to finance $80,000, the difference. Remember the points, a point is a percent. So 3 points would be 3%, and we take that percent of not the price, but the mortgage amount. So when I take 0.03 and multiply it by my $80,000, I get $2,400. Now, when they ask for the monthly payment, excluding escrow taxes and insurance, we're just saying, let's use that payment formula and see how much we have to pay just for the mortgage. So again, we're using that formula up above. I would ask that you rewrite it, but well, no, I'm not that limited on real estate here. So we'll go through and we'll put that in. Remember, this one's got that negative exponent. P is what we're borrowing, which is that $80,000. R is the mortgage rate, which is 7.5%. Again, don't forget to rewrite that as a decimal. N, because we're looking for monthly payments, we know that N is 12. T, it's a 30-year mortgage. So N times T, we're going to be making 360 payments. So substituting in, we get 80,000 times 0.075 over 12, all over parentheses 1 minus parentheses 1 plus 0.075 over 12, close to the negative 360th. Close again. And so here I'm going to type in 80,000 times parentheses 0.075 divided by 12, close parentheses, over divided by parentheses 1 minus parentheses 1 plus 0.075 divided by 12, close parentheses. Remember that exponent is negative. Use the negative key. Negative 360, close. And so I get that those payments are going to be 559.3716. They ask you to round to the nearest dollar. They don't say round up. So we'll say that our payments are that $559. To find the total interest then, again, we're going to find first the total of the payments, which is, we're paying that $559, 360 times. So, whoa, we're paying $201,240 for that mortgage. So the interest would be that amount, what we're paying, minus what we borrowed. And so for the pleasure of using the bank's money, we're paying an extra $121,240 in interest. Again, that seems quite high, but right now, you know, that interest rate is a lot higher than current interest rates. If you were to buy a house right now, I think current interest rates are closer to 4%. And so your interest would be significantly lower. Does everybody remember going through all of those steps? And again, that's what I'm asking you to do with the project, but I'm asking you to do it twice, once with a 30-year mortgage, once with a 15-year mortgage, and then to compare the overall costs of the two. Can you do this?
Yeah.
Yes.
Yes.
It's end of class time. If you need to go, you need to go. Is there anybody who doesn't need to go that would like to go back and fill in question number 15? Or is everybody all right with saying it's that same payment formula? It's just that all we're doing is the payment. We don't need those other steps. We okay?
Yes.
All right. I think a couple of people came in late. Matthew, I got you. William, I got you. And Mackenzie, I got you. I think everybody else was here on time. This test will be available for you from now until, again, the end of the day, Saturday. On Friday, we'll start going over that practice final. And whatever we don't get through on Friday, you can work on Monday. The final is cumulative. It's much longer. You'll have a longer time to do it. So we might not get through that whole thing in one period. I apologize that I wasted your time because I uploaded the wrong version of that test. So otherwise, have a great day, you guys.
Thank you. You too.
Bye-bye.